Hello, this is Matthew, and welcome to today's video, the third in my series on MUMPS, or the M programming language. In the first couple of videos, you saw a brief history of MUMPS, what it is, its historical significance, where it's used today, as well as a whirlwind tour of the language itself and its built-in database. And then we took a quick fun diversion in the second video, at least it was fun for me, I hope it was fun for you, looking at a historical implementation of a MUMPS operating system, DSM-11 for the PDP-11. But today we're really shifting to a practical look at how do you go about building a database-based application in MUMPS. And one of the convenient answers to that question is to use this piece of software called FileMan and its included component called ScreenMan from the VA's electronic health record system. So in the VA, decades ago, went off to develop their electronic health record system to start computerizing the records of all of their, from throughout their healthcare system. They developed it in MUMPS, and they developed it in-house. So as I mentioned, I think in the first video, because it was a work of U.S. government employees on the job in their capacity as U.S. government employees, it's not subject to copyright in the United States. And through the Freedom of Information Act, folks have been able to get the source code, or at least most of the source code, for the whole system. Now, the whole system is, I think it's up to something like 4 million lines of MUMPS code now. And most of it, of course, has to do with the actual healthcare application. But it's very modular, and there is a critical base component that everything else is built on top of called FileMan. And FileMan is a database management system for MUMPS. Now you may ask, didn't you say MUMPS has a built-in database? And we already saw that, right? I can write to these global variables with the little caret, my database, and I can say user M. Wilson is equal to Matthew Wilson. Sorry, this shouldn't be a write. This should be a set. And then I can come along later and I can write out that global variable. Essentially, I'm looking up some keys in my database and getting the value back. And yes, that is MUMPS built-in database. But when you're starting to think about modeling a lot of data, a lot of different types of data, building user interfaces so users can enter data into your various data files, manipulate them, run reports on them, there's a lot of work to be done between having a key value store like MUMPS gives you and having a full-featured foundation or framework, if you want to think of it that way, for building data-driven applications. And that's what FileMan does. So in this video, I'm going to walk through, I'll start with just a very brief demo of where we're going to end up at the end of the video, so you know why you're sitting here watching all of this. And we'll look at the couple of database tables or files, as they're called in FileMan, that we're going to build, and then I'll just walk through building them. So again, this isn't a tutorial on MUMPS, this isn't a tutorial on FileMan. It's going to be an introduction by way of demonstration so you can start to get a sense of everything you can do and just how expansive and capable this FileMan system is to be the database management system and really the underpinnings of applications that you may then build on top of it in MUMPS. So we will install RSM again. I'll demonstrate that one more time because we actually need to grab a particular version, and then we'll go through installing FileMan, and then we'll get into the demonstration of how to set up this database in FileMan. And then the last part will be making full screen forms that the user can use to view or fill out your database tables. And we will then probably just wrap up with another summary of the documentation that's available and where you might go from here to start building your own applications in MUMPS if you're so inclined to do so. So let's look at where we're going to end up. If I pick the right desktop here, I have a diagram of the simple database that we're going to build in FileMan. I was thinking we'll have a database where we can keep track of planets in the solar system. And those planets, of course, have a name. We might keep the mean radius. And then the first space probe or spacecraft that did a flyby of the planet and the date that that flyby occurred, or the closest pass of that first flyby mission occurred. The spacecraft might be something that we want to keep additional details on. So spacecraft can have a name, the date they were launched, the country that launched them. And one of the things that FileMan lets us do is a very relational database type layout where I can have a field in my planet file that points to an entry in my spacecraft file. So if you're familiar with modern relational databases or SQL databases, that's a very familiar concept to you. And so again, on top of this key value store and hierarchical database layout that MUMPS natively supports, we can start having some relational features and grabbing fields from other tables based on linking keys. But then because FileMan is still built on MUMPS, it's not a SQL database, it's not strictly a relational database. It also has hierarchical features. So inside of planets can have moons, and I might want to keep track of the name of the moon, the mean radius of that moon, but a planet can have multiple moons. In a relational database, you'd have to make a moon table and maybe a one-to-many relationship between planet and moons, and you'd have a separate table over here that had your moon and the radius and then the planet that that moon belongs to. But because of the hierarchical nature of the database, we can just start listing multiple moons with their own set of fields here, right as what's called a sub-file of the planet file. But essentially, you have a field in planet that has its own little structure, and you can have as many of those as you want on each planet. So you're able to mix these concepts of a relational database and a hierarchical database. And FileMan lets you model all of this. It lets your users enter data and manipulate all of this and build forms that can support this kind of schema. So this is what we're going for. And if I switch over to this page, let me get back into this, run planet on Jupiter. Whoops. Jupiter. Oh, sorry. Edit form on Jupiter. At the end of this, we'll be able to build a full screen interactive form that lets our users edit data about those planets. So again, you can see those fields I mentioned. We select the spacecraft that did the flyby, and then you also have these repeating moons where you're able to enter whatever moons you want, and you can keep entering more and more moons to add them to Jupiter. And we have this repeating little list component where we can scroll through all of those. So we're going to be able to build our data model. We'll tell FileMan how we want our files laid out, and we'll be able to build this little full screen form all without touching any MUMPS code. We're not going to have to write any MUMPS code today. These are all just features of FileMan, and FileMan has its own user interface where we can define our data models and we can build these forms. So it's pretty cool. You can imagine this is a great basis now to build your own application, because you can just build out your data model and forms, and then all that's left for you to do is to write your MUMPS code to actually drive the logic of the application to pop up a form when it's appropriate, when you want to ask a user to edit a planet or enter a planet, and you can have your business logic implemented in MUMPS code. But your user interface, in terms of the main data entry and the ability to model the data and enter the data, is all taken care of you by FileMan. So it's a very neat system. And if we go back to our data model here, like I said, this is going to be our simple little data model that we'll make, which is 2 files, one of which has a subfile. And we'll go from nothing all the way to having our full screen form here that users are able to use your application through. So let's start from the beginning. So I am on a Linux box here. This should all work under WSL on Windows, we're going to be using the reference standard M implementation. So once again, that's the one that I mentioned in the first video, where if you're wanting to dive into MUMPS and play with MUMPS, I recommend RSM just because it is a standards compliant M implementation, and you can compile it very easily, and then it's just a single binary, and it puts your whole database in a single file on disk. So it's very easy to get into, very easy to work with, and it supports everything we need. FileMan works under it, which obviously for our purposes today is the most important thing. There's one caveat, which is that actually while I was preparing for this video, I did find a bug that was introduced in later versions of RSM that either it's a bug in RSM or it's a bug in FileMan, but something about the interaction causes some display glitches when we're in the full screen capabilities mode. So we will actually build a slightly older version of RSM that does work. And in the meantime, by the time you see this video, if you're watching it a couple weeks after I post it, it's possible this bug will already have been fixed. David Wixell, who's the maintainer of RSM, has started taking a look at it, and when he has time, he'll be able to dive into it more. So he's aware of it, and we'll get an answer on what's going on eventually, I'm sure. But for now, we're going to build a particular version and use that for our FileMan and ScreenMan shenanigans here. So I have an empty directory here. If we go back to a web browser, there are really two important sites that we need to be aware of. One is reference standard M. So this is the MUMPS implementation that we are going to build on our system and use. And then hard hats, I mentioned in the first video. This is the community that has popped up over the years around the VA's Vista EHR software out in the open source world. So that version and the continuing patches that are released under the Freedom of Information Act, there's a whole community around keeping that up and running in the various MUMPS implementations outside of the VA itself. And importantly, they have a section on FileMan, and there is a version called the MedSphere enhancements to FileMan. So the MedSphere Systems Corporation, in particular, a developer there, George Timpson, who it says here was the original programmer of VA FileMan, has made a nice set of enhancements to the standalone version of FileMan. So that's, again, the version of FileMan that runs outside of the larger application of that whole Vista health records product. And this is the version that we'll use because it is up to date. It has support for reference standard M. It knows about any particular vendor-specific needs of a lot of different M implementations. So it has an option to work with RSM, which is important for us. And conveniently, the README for it specifically has instructions for using it with RSM. So VA FileMan is the version that's directly part of Vista. That's up to version 22.2. And then we'll be using the MedSphere version of FileMan, which is some further enhancements to VA FileMan, and then pulling in some of the updates from the latest version of FileMan. And we can download that here from the Hard Hats site. The last place to be aware of, if I go back home on Hard Hats, there's a Vista-related links section here. And this is where you can get to VA's Vista documentation library. So if we go to the documentation library and you go to infrastructure, here's where you can start to see all of the components that are part of the whole VA Vista system. But we're interested in just FileMan. So all of the components get a little abbreviation. FileMan's abbreviation is DI. So we're going to see that in a few places. And I imagine that stands for something like data infrastructure or database infrastructure. But if you go into FileMan here, you can see quite a bit of documentation. We have the user manual. So this is going to go over the basics of, as an end user, how to navigate some of its menus and how to use its data entry fields, particularly when you're not in the full screen forms mode. So I'm just going to fit the page here. And if we look at the contents, we can see that, again, you have things like an introduction to the layout, and then how to edit records, how to view records, how to print out reports, how to search, end user type stuff, how to navigate its prompts. So this is important when you're actually entering a lot of data, because you have a lot of options in terms of getting help, in terms of defaults, in terms of replacing portions of longer text, those kinds of things. Deleting fields is important, jumping around. And so we'll see all of that. And then an introduction to the field types that it supports, deleting records, and then using those full screen forms if those are implemented in your application. It also has a screen editor for what are called word processing forms. So basically arbitrary lengths of text. We have a screen editor and a line editor. So that's all covered in the user's manual. There's an advanced user manual that starts going through some additional things that more advanced users can do, of course. But if we look at its table of contents, you start seeing stuff like importing and exporting data, referring to fields that are linked through those relationships. So from our planet field to get at fields in the spacecraft table based on that, what we'd call a join relationship in SQL, but it's called a pointer in the FileMan system. Editing techniques for, again, more advanced editing. And then it gets into what is starting to get into more developer-oriented topics of being able to use computed expressions, some built-in functions that are available for you to do math, work with date and time, those kinds of things, generating statistical reports, and then even installing the standalone version of FileMan, some of the data dictionary reporting tools, and then getting into what we're going to start with, which is actually creating our own files and fields. So this is beginning in that advanced user's manual. So if you're looking to design your own files, database schemas, you'll dive into creating files and fields here. And then we just get more utilities. It has some audit capabilities, security capabilities. These days, I think most of the security capabilities are provided by the kernel, which is the other foundational component of the Vista software. But on its own, FileMan does have some access codes and things that your application can manage to control data access and field access in your databases. And you can see more data there. The next important manual is the developer's guide. So FileMan lets you define all of your files, and it provides your users some pre-built interfaces to enter data and manipulate data. But you can see here, 776 pages for this developer guide. This is documenting the APIs that your MUMPS code can then use to invoke the different parts of FileMan. So you typically wouldn't just drop your users straight into FileMan and expect them to manipulate your database tables the way you're going to see as we define them as the developer. But you would build your application with whatever its logic is and its menu structures and its user interface to then invoke FileMan APIs when you're ready to hand your user off to FileMan for a very specific task, and then end up back in your application code that's driving your whole application. So there are what are called classic APIs. These tend to let you launch FileMan in an interactive manner with your user. So you can tell it, okay, right, run the form to have the user enter data into this database table. And then there's also database server APIs, which are non-interactive, that allow your code to just directly do some things with FileMan. Let's see if there's, just so alphabetical order here. So cross-reference creation, deleting indexes, so some file maintenance type things, to prepare a lister, retrieve files, check data for validity. So these kinds of things where it won't invoke any user interaction necessarily, It just works with variable communication between your code and then the FileMan code to do these tasks. And then similarly, ScreenMan, this is what lets you make those full screen forms. There are APIs here, so your application code, when it's ready to ask the user to, for example, edit the planet Jupiter, you would be able to pop up one of those ScreenMan forms with Jupiter pre-selected. That'll pop up for the user to fill out, and then when they leave the form, they'll be back in your application code. And then various APIs here for handling dates and data access control, checking if the user can do something, those kinds of things. This also has the documentation for how FileMan stores the data under the covers in MUMPS globals. So this will be important because when you're writing applications, the FileMan component handles data entry, defining the data structure, all of that. But when your application wants to actually read a particular field from a particular record in a particular file or table, you actually just directly read the global that it's stored in from MUMPS. So this is when you'll fall back to seeing that, oh yes, okay, all of that data that you store in FileMan is in fact stored in the MUMPS built-in database. And this section of the developer guide here explains how that's all laid out in the MUMPS globals so that you're able to access the data that your users have entered. And then you can directly manipulate it by directly changing that data in the MUMPS globals. That's probably all we need to look at there, but just be aware that's where all of the documentation is. If we go back to, the document library, we have the user manual, the advanced user manual, and then the developer's guide. I'd say those are the three most important. There's also a ScreenMan tutorial. So this is more of a tutorial walkthrough of how to build some things in ScreenMan. You can't directly follow along this tutorial because it builds forms for files that are part of the Vista kernel. They don't come with standalone FileMan, but it's easy enough just to read through it to understand the concepts and then start building the forms on your own files, which is what we're going to do today. There's also additional information about using keys and indexes. So like a relational database, if you expect users to want to look up by certain fields in your files, you can build indexes on them, all sorts of advanced capabilities there. So let's get going. We're already, 20 minutes into the video? Yeah, we're on track for this to be a nice long video here. But again, very cool. And I hope from what you saw at the beginning of what we're actually building, if you're interested in that, this should give you a pretty good run through of how we can get to that point. So the first thing is I need a MUMPS or an M environment. So I'm going to go ahead and clone RSM here. So clone with HTTPS. I'll go to my terminal. Again, I just have a blank empty directory here. So let's grab that repository. And you can see here we have all the source code for that. We have the make files. As I mentioned, we're going to build a particular older version so that we don't have that screen layout glitch that the current version has. So I'm going to say git checkout, and we're going to switch to version 1.76.0. Okay, so now I am going to build release of reference standard M version 1.76.0. So I'm just going to type make-j. That'll do a multi-threaded make. And it won't take very long at all. Okay, so that's it. If I look now, I have the RSM executable, and that's all I need to run reference standard M. Now, we have another problem, which is that since I switched back to that old version of RSM, 1.76.0, there's actually a little bug in one of the utility routines that I'm going to want to use later. So I'm going to say git checkout main, and now I'm back to the latest and greatest. So I have the latest version of this utils .rsm file here, but I still have that binary that I built from the old version. So if I do RSM, I think it responds to just capital V. Yep, so we have version 176 of the executable, but if I look at the git log here, we are now actually up back to version 1.79.1. So just a little quirk, you'll want to build from the v1.76.0 tag, but then go back to the head of the main branch just so that we can have the latest version of utils with the latest bug fixes in it. So let's go back to my mumps directory where I have that RSM subdirectory. I'm going to set my path to include this RSM directory so that whenever I run RSM, I'll just get that version I just built. So that is under my current directory /RSM. Make sure you still then include your current path on it, and then I'll just export the path variable. So now if I say which RSM, we are getting that version of RSM that I just built in this directory. That's perfect, which is v1.76.0. The next thing we can do, and if you look over at the RSM website, the README will tell you that you can set, scroll down here, you can set an environment variable pointing to where you want your database file to live. So we're going to do that. We're going to export RSM DB file, and I'm going to put it in the current directory, and we will call it FileMan.db. That seems to be as good a name as any. Now be careful here, because the next step that the README tells you is to initialize your database with a block size of 16. If we go back to hard hats here, let's find FileMan again. FileMan, MedSphere enhancements to FileMan. If we look at the README for version 1062, which is the version we're going to install, it points out that you need a block size of at least 32K. 16K is not large enough for the FileMan compiled routines. So we're going to initialize our database with the values that the FileMan README tells us. So that's going to be a block size of 32K. We can call our volume test. That's fine. It doesn't really make a difference in RSM. I don't know what kind of support it has for multiple volume sets, and that's more advanced than we need to worry about anyway, even if it does. So let's run the command to initialize our database. So that's going to be RSM -v, so the volume set name test, block size 32. And then I think S is the number of blocks that it initially allocates or something. I don't need to give it a file name because we've set our environment variable. So RSM will always know what database file we are trying to use. And sure enough, if we look, we now have our FileMan database file. The next thing we want to do is to import the RSM utilities. So we need to go back to the RSM README to learn how to do that. And you can see that there is a file, and this is that file that we wanted the newer version of, called utils.rsm. And so we just need to run this command from the shell prompt to load the utilities into our newly created database. Now remember that utils file from where I am in my shell right now is under the RSM directory where I cloned the repository. So we're going to ask RSM to execute the mumps command, open this file as device number 1. We're then going to use device number 1. We're going to read everything in that file into a variable called code, and then we're going to execute that code. And this utils file is just a file full of a bunch of mumps code that, I skipped a step here. You actually have to start your RSM environment with RSM-J and a number of simultaneous jobs you want to support. So we'll do that. Then we'll run the utils import. So that utils file is just a file with a bunch of mumps code that creates all of these utility routines. And we need to do that because there's a utility routine here that then allows us to import routines from other exported files. So that's why we have to do that step. Back to the browser. We're done with RSM now. Like I said, I forgot to run the step where we say start the RSM process up. So that was that RSM-J12. and then we import the utilities file. So back to the FileMan README, start the environment. Again, these steps should really be in the opposite order. And then it tells us to import FileMan using that %RR utility routine. So we need to download FileMan first. So I'm going to copy the link to download Medsphere enhancements to FileMan. Copy that. Back in my terminal, we will just download that into this directory. Very good. And you can see if I do a word count lines on MSC FileMan, you're getting, 89,000 lines of MUMPS code here. So if you want to look at what does a real full-featured MUMPS code base look like, you have one right here that has all of this FileMan and ScreenMan functionality. So we're going to go into RSM, and we will run, so we'll do, that's what D is short for, do that routine called RR. I think that stands for routine restore. And now which file we want to restore from. We want that MSC FileMan file. And then it's printing out the header line from that file. So this was exported from the cache MUMPS product from InterSystems. And the comment here is that it's the FileMan routines version 1062. And it's asking to confirm, do we want to restore that? So we do a yes. And you can see here, these are all of the routines that make up FileMan. There we go. Okay, 798 routines. You can see most of them start with the letters DI. That's the abbreviation for the FileMan application in the VA's IT group that manages all of their naming standards and everything. And then there are also a number that are DD, which I think is just another component of FileMan. So when you're writing your application, you should pick your own prefix of a couple of letters, and then that way all of your routines are under your prefix, and you're not going to conflict with anything that may be under other applications. So back to the browser, it tells us in the README, after we import those, we need to rename a set of 6 routines here. So again, normally, well, I should say normally, I don't know if standalone FileMan is used a lot, but in the larger ecosystem of the Vista software, that kernel component provides certain functionality and global routines. But since we don't have that, or at least we're choosing not to install that, we need to move some of FileMan's little stub routines in place of those global kernel routines. So we need to run all these lines. We can't have the space between them because indented lines in MUMPS turn into lines in your routine, not lines that just get executed. So I think what I'm going to do here is let's go back to the terminal. We can halt to get out of RSM, and we'll just temporarily paste those lines into VI here. And we can just remove the indentation from all of these lines. And now I'm just going to use the mouse again. I'm going to copy those lines to my clipboard. No need to save that. Go back into RSM. If I paste those lines in, hopefully it will just run those 6 commands in sequence. Yep, that looks like it worked. So now that we have those routines in place, we can go back to the README, and we should be at the point where it tells us that we're ready to initialize FileMan. Yep, so we're going to run the dinit routine, which initializes FileMan. So do caret dinit. All right, VA FileMan v22.2, initialize VA FileMan now. We can say yes. So the site name, we can call it whatever you want. I'm going to call it Matthew Test. And then the site number, again, in the VA health system, they would assign each site a number. We'll just use 999. That's used as the prefix for file definitions that get created. So if I want to export my data dictionary definitions for this application I'm building and import it on another system, by having a unique site number, I'll have unique file names essentially for all of the tables that I'm creating. All right, type of MUMPS system you're using. If I hit a question mark here, you can see the options, but we see here that we have RSM or MUMPS V1, which is the product that RSM was based on. You can still, it actually still supports DSM for OpenVMS. It's a little bit trickier to get up and running on that. And this MSC distribution of FileMan actually doesn't quite include one of the routines that is necessary. You'd have to pull from the real VA FileMan. But anyway, neither here nor there. So you can see GTM, Unix, YadaDB. This is the other MUMPS product that's open source for Linux that you might choose to do your MUMPS experimentation in. So you can follow a similar process here to get this up and running in GTM on Unix or the fork of GTM, YadaDB. We're using RSM, so I'll just enter RSM here, and it will finish setting everything up. Okay, so that's it. So we have installed FileMan. So let's just go ahead and dive in. The way you get into the programmer mode in FileMan is you do p caret di. So that's kind of the programmer's entry point to di, which again is that abbreviated name for FileMan. This is a syntax that we didn't talk about in the quick tour of the MUMPS language. Usually we executed routines by saying do and then the caret and the routine name. But routines can have multiple entry points. So we're saying we want to start at the label P inside of that routine DI. So if that makes sense, this is basically just the name of the entry point into this routine. And if we hit enter, you can see we are in MSC FileMan 22.1062. So that matches the version that we downloaded. So far, so good. Now we are in FileMan. And we're going to start seeing a lot of conventions that are similar throughout FileMan. So when I'm prompted with a menu here, I can hit question mark if I want to know what I can enter. Sometimes you can get more information with 2 question marks. If there were a long list of options, a single question mark would just say answer with option number or name, but then it would say, do you really want to see the whole list of options that are available? There are only 9 here, so question mark gives me the whole list. But if I know I want to see the whole list and I don't want it to ask me, I can always just get the whole list with question mark. And when you're at these menus, I can do it by number. So I can say 1, and that will then confirm, yep, that's the enter or edit file entries option. And I'm now in enter or edit file entries. If I just press enter without putting anything in, that takes me back up a level in the menus. So I'm now back out at the main select option menu where I was when I went to enter or edit file entries. You don't have to remember the numbers. You can just type in the beginning of a name. So if I want to go to inquire to file entries, I can just start typing IN, hit enter, and it will auto-complete that out to inquire to file entries. On this menu, I don't think there's anything ambiguous, even just based on the first letter, no. But if there were a couple of similarly named options and you typed in the first few letters, it would then just prompt you to pick 1 or 2. It would narrow the list down for you, and then you just say, oh yeah, I want number 1. And so that's just sort of basic navigation there. When you're at this top select option menu, if you hit enter, it just dumps you back out into MUMPS. So now I'm back at my MUMPS prompt. So I have to go back into FileMan by doing do p caret di. So now that we're in FileMan, we can start defining our file attributes. So again, what you might think of as database tables. So in our little diagram here, we have these 2 tables. These are called files in FileMan. Hence, it's the file manager. So because I'm going to point to spacecraft from my planet file, I'm going to define the spacecraft file first. Also because it's just a little bit easier, so we'll be able to see some basics before we get into a couple of the more advanced concepts in this. We're also going to use just the plain, what's called the roll and scroll, just this plain terminal text interface to define the spacecraft file, so you can see that. And then you'll see that we also have the option of using some forms to define file, or at least fields in files as well. So we'll do that for the planets. But let's start with spacecraft. So we're going to make a spacecraft file that has 3 fields: a name, the launch date, and the country. So back over in FileMan, I can say modify file attributes. This is how you define, create, edit, change files. It's asking if I want to use the screen mode version. For now, I'm going to say no. Again, you saw another convention here where the default value is going to be presented 2 slashes as kind of the prompt. And if I had just hit enter, I'd get the default of yes, of course, but I said no. And then it asks, what file do I want to modify? Well, I can hit 2 question marks, and it's just telling me that I can enter a new file if I wish. What does 1 question mark do? Oh, so I lied earlier about how some of the question marks work. In this case, there are existing files. If I say yes, oh, actually, no. So it's not letting me modify, or it's not listing any of the built-in files. So that's why I didn't get anything with question. Nonetheless, I can make a new file here. So we're going to call this file spacecraft. And it's asking me, am I adding spacecraft as a new file? Just to make sure I didn't mistype an existing file that I meant to edit versus creating a new file. So every file gets assigned a number. You can see that site number prefix, and then this is just the next available number under my site number. So I'll accept that as the default. And then internal global reference. This is important. The default is fine, but essentially what it's asking you is what global in the MUMPS database do you want to store the data, the rows, if you want to think of it that way, for this file in. And by default, it's just going to store them all under this DIZ global with your file number as the first part of an array index, and then it will build the rest of the array indexes for whatever the particular data is, right? So this looks like kind of an incomplete global index syntax in MUMPS, which is what you need to put here. So in my case, I'm actually going to store this in a new global called spacecraft, sort of abbreviated here. And then I need the open parenthesis because FileMan will then fill in lots of levels of array indexes to actually store data in this global. So I don't need the file number here because I'm just going to dedicate this whole global to spacecraft. So that is going to be the beginning of the MUMPS global that data is going to be stored in for the spacecraft file. And the reason you might want to do that instead of just everything under a single global is that MUMPS implementations tend to let you manage storage, optimization, and monitor space and index efficiency just at this top global level. So a certain FileMan file maybe is performance sensitive, and I want to put it in a global that I've configured my MUMPS implementation to store on an SSD, whereas I have a bunch of bulk data in a different global that I'm fine putting on spinning disks, something like that. So that's kind of the level at which the MUMPS implementation lets you map where things are stored on disk and in your environment. Now it's telling us that it has created a free text column field called name, and it's assigned it a particular field number. So every time you create a new file, by default, you get a first field for free that's a free text called name. Now, you can edit that field. So if I say select field name, I'm actually now just editing that existing field. So instead of all capital name, I'm going to rename it to have capital N and then lowercase a-m-e. And we can skip these other fields it's asking us about. Description is actually a word processing field. You can have lots of lines there. Data type, yep, free text. So again, if I hit enter, it'll just accept the existing default. And now it's asking minimum length, maximum length. So again, you're going to get a 3 to 30 character name field by default. If your field should be a number or something else, you can actually change the data type from free text to something else, but we'll leave it name. 3, yeah, I can't think of any planets in our solar system with fewer than 3 letters, so that's fine. Maximum length, again, you could extend if it made sense. And then FileMan can also enforce an input pattern. So you have to look up the syntax for MUMPS pattern matching, but you're able to set up an actual input pattern match to define what valid data looks like. And then is it mandatory? Well, yes, it's essentially the primary key for the field. Help prompts. So basically, those are the attributes that define a field in your file. Another important note, this field number .01, this one that automatically creates, is essentially the primary key for this file. So when we're making the pointers to other files, this is the primary key that you link them on, whatever you define as your .01 field. Okay, so that's the first of our spacecraft. Actually, I said I can't think of a planet. This is actually the spacecraft name. So I can't think of a spacecraft that had fewer than 3 letters. Don't mean to confuse you and think that we're defining the planets file now. Okay, so another field. Again, if I hit question mark here, you can see we only have one field so far, that name field that got created. But looking at our schema, we wanted a launch date field. So I can type in launch date. And since there isn't an existing field called launch date to edit, FileMan is prompting me if I intend to add something new called launch date, the second field. So I can just say yes there. It will assign a field number sequentially. I'll accept the default. When you're getting into designing bigger data models, you can organize fields by number and sort of subfield numbers. You can check the documentation. You can look at how some of the built-in files are defined if you're interested in that. Data type of launch date. Let's look at the data type list. You can see all of the data types that we're able to store in a FileMan field. So in this case, I want a date time field. So I can, again, type the number, or I just know, okay, I want something that's date, and it'll autocomplete that to date time. Do I want an earliest date? Nope, we'll just accept anything. Can the date be imprecise? Well, what does that mean? That's a question mark. So would it allow February 1980 instead of February 5th, 1980, for example? No, I think we're pretty sure of the specific day that we launch space vehicles. Can a time be entered? Okay, so this is how a date time field can be either just a date or a date and a time. There's a separate field type for just a time. So in this case, no, we don't need the time of day. We're just going to store the date. And can I have multiple launch dates? Nope, just a single launch date. So subscript and piece position, this is how, where under that global, FileMan will actually store the value for this specific field. So we'll look at this a bit later, but for now, we can just accept the defaults. Is launch date mandatory? Sure, we should know when space vehicles are launched. And then we can enter the help prompt. So launch date of the spacecraft from Earth. So that's what will show if I just hit a question mark when the user is being asked to fill in that field. Executable help, I'm not sure what it does. I think you can actually define some MUMPS code that could dynamically generate help or pop something up or do something else for them. And then description is a word processing field where I can provide even more help or even more of a description, perhaps for the question mark help on the field. So again, in this case, I probably don't need to, because launch date of the spacecraft from Earth is probably pretty self-explanatory. But I might want to enter more text and say, please enter the date the spacecraft was launched from Earth. If I enter there, I can enter more lines, and maybe the UTC date, just to clarify that, if it was around midnight, we want to pick whatever day it was, UTC. You can hit enter to get out of entering multiple lines of text. You can just hit enter here and you'll move on to the next field. But I want to show you that you can also, this is a line editor. So you can delete lines, you can print out the lines, you can move lines around, you can search for a string within that word processing document. But if I go utilities, and if I say change editor, editor change, E, not C, you can see that there is a screen editor in addition to this line editor that we're using. So if I say screen editor, now I actually have a full screen oriented editor where I can, type text in UTC time. If the date, whoops, that didn't quite wrap correctly. If the date is unknown, well, you should probably consult an encyclopedia or NASA's history of spaceflight. So this is a full-fledged screen-oriented document editor. So you get the idea there, right? And if I hit F1H for help, you can see that there are, in fact, a lot of different commands I can use, moving around, deleting, formatting, reflowing paragraph text, searching and replacing, copying and pasting, all sorts of good stuff there. But importantly, use Control E to exit. So I'll just say Control E. Do I want to save the changes? Yes, please. And under edit option here, okay, so now if I hit enter, now we're back to, define the next field in my file here, right? So again, we just finished defining the launch date field. So the last field, if you look at the diagram here, we also wanted country. So let's make a field called country. Am I adding country as a new field? Yes. Field number's fine. Data type here, I'm going to say set of codes. So this is essentially an enum field where I have a limited set of options that the user can choose from. Now, internally, it can store a value. So I'm going to say USA. And then what does USA stand for? So we'll call that United States. And then internally stored code, maybe another country that was launching spacecraft during the initial planet flybys was USSR, which is Soviet Union. And then just hit enter when you're done entering the possible codes that people can pick from for that field. Should country entries be screened? I'm going to say no. I think this lets you limit the options that they can select based on running some code that can look at other input values and all that. So that's more of an advanced feature. Will country be multiple? No, we'll just allow a single country per spacecraft for now. And then again, subscript and piece is where the data will actually be stored. And is it mandatory? Sure. We'll require a country. Help prompt, I don't think we need any. I'll just hit enter through all of these fields. So that's it. That is my entire spacecraft file. So let's hit enter one more time, and we're now back at the main FileMan option menu. So you can see here, I can choose my FileMan option. Okay, one down, one to go. So let's enter our planet file, or define our planet file. So that's going to be modify file attributes. This time we will use the screen mode version, and you'll see what that's all about. So modify what file? Well, we last edited spacecraft, but now I want to edit the planet file. Yes, planet's a new file. It will assign a file number for me, so that's fine. And again, I'm going to store planets in a new global called planet. So I'll just type in _planet and then an open parenthesis, because FileMan, when it's storing data, again, will add array indexes and the closing parenthesis as needed. Okay, so it gave me that name field again. I want to edit that name field. Now this time you can see it popped up a form. So this is what the full screen field editor looks like. Instead of asking me question by question, I can just start filling out the form. If you hit enter, it'll move through the form in the developer specified order, and it will trigger any actions that need to be taken on fields that you move through. So we're going to leave this free text, but you'll note when I hit enter on the free text field, it pops up the parameters for the free text value. So minimum length, 3 to 30 with that pattern match is fine for planet names. Then when you're done with a form, you end up down at the bottom here to do a ScreenMan command. So in this case, close is fine. So I'll just keep hitting enter. And you'll note that it skipped me all the way down to the help prompt because it doesn't suspect that I want to edit or change anything else about this field, which is actually correct. I just want to change the help text to maybe please enter the planet name. I'll hit enter, and now I'm done filling out that form. I can do a command. So exit saves and exits, whereas quit quits without saving. So typically you just want to do exit, and that will save the data on the form. So now if you look at our field list, you can see that the name was renamed to name. So let's just quickly define our planet fields. So looking back at the diagram, you can see our next one is going to be mean radius. So I'm just going to type a field named mean radius. Yes, I'm adding it as a field, accept the default field number, and we get a form to define it. So data type here is going to be number. So I can just partially type in the word number. Answer with data type number or name. Oh, I think I need to capitalize it at least. Numeric. It doesn't have a B in it. That's why I didn't accept it. So numeric, lower bound, I don't know, 1 up to 100,000 will cover all the planets in our solar system. It's not a dollar amount. And then do I want any number of fractional digits? Sure, we'll accept tenths of kilometers. Now, in this case, for a pop-up, we will just accept close. So I'm just hitting enter to move through these fields. Is this field a multiple? No. Planets can only have one mean radius. So I'll hit enter. Now I'm getting that subscript and piece position prompt that we saw from the roll and scroll interface. I'll accept the defaults here. Close that pop-up. And here I can say, enter the mean radius of the planet in kilometers. Enter, enter, exit. Okay, next field. First flyby craft. Okay, this will be exciting. First flyby craft. Yes, it's a new field. Default field number. Enter. Data type for this is going to be a pointer to a file. So which file do I want to point to? I want to point to spacecraft. I can type a partial name there. It will autocomplete because I have enough for it to be unique. And then this is an interesting option. Shall adding a new file entry, LEGO, be allowed? LEGO stands for learn as you go. So what this means is that if I'm adding a planet, if this is no, I would have to enter a spacecraft that already exists in the spacecraft file to fill in this field. But if I say yes here, it will let me add a spacecraft right as I'm adding the planet. So I'm going to say yes here, and we'll see what that looks like later. So close that pop-up. And then again, screening. This, I think, lets you limit the spacecraft from the spacecraft file that you might be able to choose from by running MUMPS code. So I'm just going to say no here. We'll close that pop-up. Is the field multiple? No. There can only be one craft that first flew by the planet. And then here's that subscript piece position. I'll accept the defaults by hitting enter. Help prompt. I don't think we need help here. And no executable help. So I can exit that form. So that's how you define a field that points to an entry in another file. Now, first fly by date, this will just be a date field on Planet again. So let's go back and say first fly by date. Yes, it's a new field. This is going to be a date. And here you can see the same questions that it asked us before about earliest date, last date. Can the date be imprecise? Sure, maybe we don't know the exact day of the closest approach. I mean, we do, of course, but we'll allow it in this case. We don't need a time. We'll just take the date. If you do allow times, you'll be able to say include seconds and is the time required or is just the date good enough? But that's all good. It's not a multiple, except the default subscript and piece position. It auto-generated help text based on the fact that we had no minimum and no maximum date, but I'll provide more helpful help, which is enter the date of the closest approach by the first spacecraft. And we can exit. So the next field is going to be this list of moons. So this is what's called a multiple field because you can have multiple moons and then they can each have their own subfields. So back on our system here, we're going to call this field the moon. And I'm not making it plural because it's actually the field moon that we can have multiple of. So each moon will get a moon name, for example. So we'll call that moon. Yes, it's a new field. And the data type is going to be free text because I can just type in the name of a moon. Let's see. Is it free space text? Yep, free space text. We'll say just 3 to 30, kind of the typical. I don't worry about a pattern match here. And then it asks, is this field multiple? I'll say Y and hit enter. Aha. Should user see an adding a new entry message? I'm going to say no, just because that's a little bit annoying when I'm adding a bunch of moons. And then having entered or edited one multiple, should the user be asked another? Yes, we want to let them keep entering moons until they just hit enter on a blank moon name, basically. We'll save that. Please enter the moon, the moons of the planet. Now, this is going to be very important. Because we are going to be able to store multiple moons, and each moon will have its own set of fields that we can store with it, it's no longer saying I'm going to put this data in subscript 0 and a piece position. Instead, we're going to store it in subscript 1, so another array index under that planet's global. And the definition of what a moon is, so the fields that we can have on the moon, gets its own subdictionary or subfile. So I'm going to make a note of this subfile number because I'll need it when I'm making the form later. We can always look it up again, but since I know I'm going to need it later, I'm going to write down 999003, which is the planet file number, but then .04, which is essentially just built from the field number, which happened to get assigned field 4, as you can see up here. Okay, so hit enter there to accept the subdictionary number and close that pop-up. So now when I exit that, you can see it's no longer asking me select field. We're now defining the subfields on a moon. So if I hit question mark here, you can see that we already got, again, sort of the primary key of the moon. This is the moon name. But I can also now add additional fields per moon. So I'm going to add mean radius of the moon. And even though we already have a field called mean radius on the planet, we're now in this little scope of just the moon. So I can have another field called mean radius. Yes, I'm adding it as a new field. And you can see here that I can say numeric. Again, maybe moons aren't going to have radiuses of more than 40,000, I would think. Not a dollar amount. We'll accept 1 decimal point of precision. Close that. Is it multiple? So you can actually have multiple levels of multiples. And again, this is that hierarchical fan out model. But no, in this case, a moon can only have 1 mean radius. So within the moon entry, we now have the subscript and the piece position that this field is going to go to. And help prompt, please enter the moon's mean radius in kilometers. Exit. So now if you say question again, you can see that our moon has 2 fields, the moon name itself and then the mean radius. I'm done defining fields in moon, so I'm just going to hit enter. Now I'm back to defining fields in the upper level, the planet. And you can see here that we now have all of our fields on the planet. Its name, mean radius, flyby craft, which is the pointer to the other table, flyby date, and then multiple entries for each moon the planet has. So let's check our diagram. That's everything. So we have finished defining our data model for these 2 files. So I'll just hit enter. That gets me out of the modify files. I'm now back at the top FileMan menu. Well, what can I do now that I've defined my files? Of course, I can enter data in them. So to actually use those tables, I can say enter or edit file entries. Before we do planets, let's go back to the spacecraft file. And it's asking which fields in that file do I want to edit. So if it's a large file or with a lot of fields, and I know I only want to update a couple of attributes on some records or enter a new record but only fill out a couple of fields, I can have a limited set of fields. But in our case, we just want to edit all. So I'll just accept the default all fields. Spacecraft name, well, there aren't any spacecraft yet. So the list is empty, but I can add Pioneer 10. Are you adding Pioneer 10 as a new spacecraft? So again, you can see that the FileMan file attribute definition itself is actually just the FileMan enter and edit interface for files. And the file table is where it stores all of the definitions of the files that we've created. So yes, I am in fact adding a new spacecraft. The launch date of Pioneer 10 was March 3rd, 1972. It's pretty liberal in how you enter dates. We'll see that in a minute here. So I can say March 3rd, 1972. The country here, if I don't know my options, we have the list. I can either enter the code or I can enter part of the value United States, and it will automatically recognize, yep, United States is what I mean, and it will put the code in USA behind the scenes. So that's our first spacecraft. We can also define maybe Mariner 10. Actually, I'm going to do that later for a different reason. Let me do Pioneer 11. Yes, it's a new spacecraft. Launch date. Launch date of Pioneer 11 was the 6th of April. So maybe I'll type 6 April 1973. Again, I entered the date in a different format there, but it correctly picked up April 6th, 1973. And once again, USA. And that's enough for defining spacecraft for now. One thing I will note, if I go enter spacecraft, I can edit all fields. You can see that we do, in fact, have those 2 spacecraft in the database. If I type Pioneer 10, I'm able to edit the existing spacecraft. So I can change its name or just hit enter to take the default. I can change the date. If you want to delete a value, instead of just hitting enter to accept the default, you can use the @ symbol. But because we marked that as a required field, I do actually have to have a date here. So I'll just hit enter to accept the existing date. Same with the existing country. I can delete an entire spacecraft by deleting its name, its primary key field. So if we go back into Pioneer 11, and the name here, if I just replace name with the @ sign, that's the delete operator. And it says, are you sure you want to delete the entire record, the entire Pioneer 11 spacecraft? Nah, we'll leave it in the database. If I just want to get out of this after making some number of changes, I can hit two carets up, and that will exit out of that data entry form that I'm in. You can also jump around by, if it had more fields, you can do things like caret and the beginning of a field name, and it would jump right to editing that field. So that's all the kind of stuff that is in that the FileMan user's guide, is all of the operations and all the things you can do to efficiently move around this interface for entering and editing data. And as you can imagine, it is built as a scrolling terminal interface to be pretty efficient and let you do things quickly once you really learn the system. So it's worth checking out the user's guide just to see the sort of stuff you can do there. All right, so that's it for spacecraft. Let's add a planet. So I can say enter again, and I can say planet. And again, we'll just do all fields on planet. Let's add the planet Jupiter. Yes. Mean radius of Jupiter, I did my homework ahead of time, is 69,911 kilometers. The first flyby craft was Pioneer 10. And you can see it just accepted that because that is, in fact, an entry in the spacecraft file. And the first flyby date there was December 3rd. So I'm going to use yet another date format. So month, day, year. So 12/3, and I'll just do a partial year, 73. And yep, it got all right. December 3rd, 1973. And now select moon. So of the moons that have been added, there aren't any yet. But this is like selecting a planet name. So select moon. Let's just add Io for now. Oh, did we not turn on? Oh, we made it 3 letters or more. That was a mistake. Moon names need to be shorter than that. So I'm going to get out of that. I'm going to go back to modify file attributes. We'll use the screen version. I'm going to edit planet. I'm going to edit moon. No. I'm going to edit moon. There we go. Sometimes case can be a little bit important. So that's moon. We don't need to edit the help here. Sorry, Control E out of that. Let's just go down and exit that. Okay, yeah, so now we're editing the moon subfields. So here we can edit that moon name subfield. Yeah, and this is where we got in trouble. This just needs to be 1 or more characters. Close that. Now, one trick here, right? I'm hitting enter to move through these various fields. You can hit F1 and E for that exit action, which saves and exits. Also, any field you're in, you can just type the caret and hit enter, and that will jump down to the ScreenMan command line here. And then here's where I can say exit. Since I've changed the field definition, the existing moon data will be checked for inconsistencies. So that's fine. This is where if I maybe used to allow 1 to 10 characters, but now I'm allowing 5 to 10 characters, it would give me a report to call out any existing data that maybe no longer meets the field validation requirements so that I'm aware of it and I can go choose to do something about it. Okay, but that's it. I'll just hit enter until I'm back to the main FileMan prompt, select option. Now let's go ahead and enter or edit planets again. And I'm going to go back and edit Jupiter. So if I partially type in the word Jupiter, because it's an existing planet, I'm now editing Jupiter. Accept the defaults. But now I can enter Io as a moon. Yep, so it accepted Io as a moon. Io's mean radius is 1,821.6 kilometers. I can enter another moon. Let's enter Europa, which has a mean radius of 1,560.8 kilometers. Again, at this point, I can select an existing moon to edit. If I wanted to delete a moon, right? If I enter the moon, hello. Oops, that's not a real moon. I can edit the moon hello and type the @ symbol to delete it. Yes, I want to delete it. Now I'm just back to the 2 moons. But if I just hit enter, we're done entering moons. And in fact, because that's the last field of planet, we're done entering the planet Jupiter. So now I can enter another planet name. You note if I type JUPI, I automatically get Jupiter. Well, what if I actually want a new planet named Jupiter? I don't want it to autocomplete to that existing name. So here, if you enter in quotation marks a name, that will let you use that exact value and not try and find an existing planet that you might be trying to talk about. So in this case, no, I don't want to do that. But if you run into that situation, that's how you get around the sort of auto search, autocomplete. Let me quickly enter Mercury. There are no moons, so this will go pretty quickly, just so that we have a couple of planets. Yes, mean radius of Mercury is 4,880 kilometers. Oh, no commas, just 4880. Now, the first flyby craft of Mercury was Mariner 10. Mariner 10 isn't in the spacecraft table, so this is that learn as you go thing. We said that yes, users are allowed to enter new spacecraft entries right from this planet form, right from this field. So yes, I want to add Mariner 10 to the spacecraft file. I'm not sure if you can have it then prompt for some of those required fields. Like we had a required field for launch date, and then I think we might have even made country required, but it didn't ask me for that. So I guess technically I have invalid data in there now. When you're doing the forms, you are able to have it pop up and fill out a record. I'm not sure if there's a way to force that or to do that from this interface. Nevertheless, we're now in the next field of planet. So the first flyby date, or the closest flyby date of the first flyby craft for Mercury, was 29 March 1974. Mercury has no moons, so I'll hit enter, and that's it. We're done with planets. I can enter the rest of the data on the Mariner spacecraft by editing spacecraft, editing Mariner 10, and I can give it a launch date of November 3rd, 1973 from the United States. All right. Well, thanks for sticking with me so far. We now have our tables defined, our files defined, and we have data in the database. So what else can we do at this point? Well, it'd be nice to be able to print out some reports about our planets. So that's what print file entries does. If I just want to look at one, I can do inquire, and we can look at the planets. We can say Jupiter. You can list multiple planets if you want to see the details on multiple, but we'll just say Jupiter. We'll hit enter there. Standard output's fine. Don't need computed fields. And you can see here, I can just get a quick printout of the fields in that record. So Jupiter, its mean radius. We see the first flyby craft. We see the date we entered, and then we just get a list of every moon and its mean radius. So that's one thing we can do. We can also print file entries. So if I say print, we'll again pick the file that we want to look at. So planet. You can choose what order I want. I'll sort by name. And which planet do I want to start with? So you can do a subset of the planets, but I'll just start with the first planet, and then that'll go all the way to the end in that sort order. And then I say what fields I want. So I can list the fields individually, right? If I had question mark here, you can see that we have the various fields to choose from. You can see some hints about I can do format specifiers after a semicolon. If I have a template of print templates, I can do that, but we don't have any of that. Let's just say all, and that's just a magic keyword. Do you mean all the fields in the file? Yes. I'll give it a title. And you can see, okay, so it prints out my list of planets, but this isn't really what I want. It's giving me a lot of room for the planet name because it could be up to 30 characters. And so that's sort of pushing the first flyby date down to the next line. And then it's starting to list the moons with their data here. And I'm not getting any information about Pioneer 10, right? What if I want to see the date that Pioneer 10 launched in addition to that date that we just put right here for the flyby? So this is where you're able to say print and really fine tune what you want your field output to look like. So output from what file? I can say planet, sort by name. That's still fine. We're going to start at the very beginning. But now I can say field by field what I want to appear. So I do want the name, and then I'm going to do semicolon L10 That's going to make it left justified and then truncated to 10 characters, and that'll be fine for our planets. Next, we'll take the mean radius. And I think for this report, that name is probably a little bit long, so I can give it an alternative title or header up at the top there. So I'll just call it radius. Next up, we have the first flyby craft. So we'll call that first flyby craft. And again, here, I probably don't need anything more than 10 characters. So I'm going to limit that to 10. And I'm going to call that maybe first craft, just so the title is a little bit more compact. Now what I want to do is get the launch date of that craft. So I'm going to refer to the first flyby craft field again, but then I'm going to do a colon, and this lets me access the fields in that related table. So if I switch over to our diagram again, because first flyby craft points to the spacecraft file, I can now refer to the launch date field inside of spacecraft via that first flyby craft pointer. So back in the terminal, we'll do colon launch date. And I'm going to do a semicolon. So I'm now in the field options, and I'm just going to say launched. So that'll be the column header. Okay, it accepted that. So far, so good. And now back in the planet file, I'll take the first flyby date column, and we'll just call that flyby date. Okay. Oh, it didn't know. Oh, not colon, semicolon. So first flyby date, semicolon, and then flyby date for the column header. There we go. It accepted that. And I guess at that point, we just need the moons. So let's say moons, or sorry, not moons, moon, the multiple field. So now it'll ask which fields of the moons do we want to print. So again, at this point, we're in the moon subfields. So I'm going to print moon and mean radius, but we can just title that radius. I'm done with moon, so I'll hit enter there. And in fact, I'm done with my whole report, so I'll hit enter there. The heading, we'll call this list of planets, nicely capitalized. And because I just went through a lot of effort defining these fields that I wanted in my print report, it is offering to store this print logic in a template for me. So yes, I would like to do that. I'm going to name this the planet list. Am I adding planet list as a new print template? Yes, I am indeed. Okay, so it has generated that printout, and it has also saved this column layout to that template for me. And you can see this looks much nicer. We have a first row of data per planet, which is the name, the radius, the first craft that visited it, the date that craft was launched, and then the closest approach date. And then for the moons, we have indented under that the moon and the moon's radius. So again, I could have cut the moon field short a little bit to move that number closer, but you get the idea. So you can see Jupiter here with its data. It's pulling the launch date of Pioneer 10 from the spacecraft file. And then we have its moons. And then, of course, Mercury with Mariner 10, and it has no moons. So if I go back into print again, and I print from planet, I can choose my sort order. I can choose which planets I want to see. But then when it asks for the fields, I can just type my template in the square brackets. So planet list. If I hit enter, it's asking, do I first want to edit that template? Nope, we'll just accept that template as it is. And it will default to the title of the report. But again, if I sorted it differently, or if I did a subset, I might want to print a different title at the top. So I'll just accept the default from the template. And then once again, it printed out my list of planets. Now, here's the point where a sane YouTuber might say, let's end this video here, and we're going to do a part 2 for ScreenMan. But I'm going to give you everything in one video so that you don't have to wait and watch another advertisement, pre-roll ad on a new video and try and drive more clicks to my channel. We're just going to dive right in, and we're going to make the full screen form to edit these planets. Because again, at this point, you may be done. You might say, you know, that interface here where I'm able to edit planets by just answering questions one after another, maybe that's all you need for your application. And you can write your application code to just launch users directly into filling out this user interface. Right, you can call FileMan and tell it, why was I editing Europa there? That was kind of funny. You can tell it that you just want to launch in to edit a particular planet and give them that. But at the beginning of the video, I promised we'd build a full screen interface for this. So that's what we're going to do. So back in, oh, actually, let me show you one thing really quickly here as an interlude. Remember, we're storing all of the data in globals in MUMPS, right? So there's a utility routine here for global directory. And you can see that sure enough, we have the planet global and the spacecraft global. So let's look at the spacecraft global. If I just do the utility routine called %G, I can use it to just dump out part or all of a global. So we're going to dump the entire spacecraft global. And now you can see how FileMan actually stores the data in the MUMPS database. So in the multi-level array database that is built into MUMPS. So we have the spacecraft global and the parentheses, right? This part right here is what I told FileMan I wanted to use as the beginning sort of variable and index of this file. So then everything after this is going to be the array indexes that FileMan adds and uses. So every entry in a FileMan file has an, I think it's called an EIN, entry internal number. So that's what this 1, 2, 3 is for. So from the user's perspective, the primary key is really the first field, but internally, FileMan can refer to each entry by its actual internal identification number. So that's the first level of indexing under whatever I say my base global is going to be, is the entry number. And then under the entry number, this is where you have those, what did they call it? The sub field, the subscript, I think they called it. So I said that, you know, the name goes in subscript 0, piece 1. And the launch date goes in subscript 0, piece 2. And finally, the code for the country goes in subscript 0, piece 3. And if you saw in my first video that this piece layout, and particularly caret separated piece layouts, is a common theme in MUMPS. And MUMPS has that $piece function to help you retrieve individual pieces out of this and then actually update individual pieces inside of that. So this is how it's all laid out in the actual internal MUMPS globals database. And the reason that you might have more than just subscript 0 on this is A, for multiples. We'll see that when we look at the planets. But also different MUMPS implementations have different limits in how big a value can be in a variable. So if you have a 255 character limit, you might have more field data than fits in 255 characters. So you can start breaking out your data fields into different subscripts and then different pieces within the subscripts. You could break it out such that every field was just in its own subscript, 0, 1, 2, 3, 4. But again, that sort of gets into data modeling and then the efficiency of working with your various data models in FileMan here. The other thing you'll notice is that it creates this string index B. This B index is, again, essentially the primary key index. So FileMan will automatically create an index on the primary key field. And this is how it can quickly look up, okay, right, if the user starts typing in, MARI, it's going to check the primary key index, the B index, for the spacecraft file for the second level indexes that start with MARI. It'll find Mariner 10, and then it will directly know that it can jump to spacecraft index 3, and that's how it directly looks up a full record out of this particular file. So that's kind of the internals of how it works. And the 0 index on any file is going to be just the file name itself, the file number, and I think it's the number of entries, and then the last assigned internal entry number. So that's how it knows when I add a new spacecraft, it's going to increment this, call it number 4, and then put the data in for number 4. So if we look at the planet global, you can see how those planets are stored. And again, this is slightly more complicated because we have those multiple moons, but it's the same idea. There's the metadata for the planet file itself, which is planet 999003. There are 2 entries. The last assigned ID was 2. Planet ID 1 is Jupiter. Planet ID 2 is Mercury. Jupiter has its information. Subscript 0, piece 1, subscript 0, piece 2, subscript 0, piece 3. These dates, by the way, this is FileMan's internal date representation, which you can see here. This was December 3rd, 1973. So it's year, month, day, but then it also has a century indicator. So 2 is the 1900s. I think 3 would then be the 2000s. If you were doing a date in 2020. So it is Y2K compliant. So there's the century indicator and then the YYMMDD for the date representation. 1 here, so this is the pointer to spacecraft. So for actually storing the pointer, it uses that internal ID number, even though we selected it and it displays based on the name. But internally, it links it by ID. So if I change the name of Pioneer 10, Jupiter will still stay linked to whatever the new name of Pioneer 10 is based on the internal ID 1. And then what was this? That's the radius. Okay, yeah, so that's just a data value. But then the subfile for moons is file 9990003.04. And again, for just Jupiter, it has its own IDs. So under subscript 1 of Jupiter, we have however many moons it has, and they each have their own internal ID directly under Jupiter. And then that's where you can see subscript 0, piece 1 of the moon, subscript 0, piece 2 of the moon, subscript 0, piece 1 of the moon, subscript 0, piece 2 of the moon. Moons have their own index. So under Jupiter's moon, right? So we're still on 1, which is Jupiter. We're in subscript 1, which is this moon subfile. There's a primary key index, a B index across the moons for being able to look up and figure out which row IDs correspond with a name that a user is searching for. And then Mercury is simple because it has no moons, so there's no subscript 1 under Mercury. And then you have the B index of the planet file itself, Jupiter and Mercury. So that's how it's all built out. And again, if you're writing your application on top of these files, you need to become familiar with how these are laid out, because the FileMan API, where you might say, okay, user, look up a planet, they type in Jupiter, FileMan will figure out, the user wants planet internal ID 1. It's then up to your application code to grab the values that you need from planet ID 1 and then the subscripts of the various fields. So when you're working with developing on top of FileMan, they actually give you data dictionary utilities to help you understand the layout of the files that are there. So if I look for a list of file attributes, I can look at the planet file, and there's a number of listing formats. So standard is pretty verbose. But if I go global map, for example, 6, this gives me a report of the fields in this file, planet, that shows how those globals are laid out and where each field is. So of subscript 0, you can see that piece 1 is a free text field called name. And then there's the little caret there. And then piece 2 is a numeric field called mean radius. First flyby is the third piece, and it's a pointer to this file over here. So that's the file number of the spacecraft file. And then for the moons, it lays out, you can see here that the moons are going to be subscript 1 under the record ID, the internal file, or the internal ID number. And that under the moon, you're going to have the moon's ID. Subscript 0 is going to be the first piece is a free text field, and the second piece is a numeric field. It also tells you any print templates. So you can see that in this report, it's telling me that there is print template number 1 is called planet list. So again, as a developer, I now know that from my application, I can ask one of those FileMan APIs to print out the print template number 1 to get the planet list template. And I can just directly invoke that so that if there's an option in my program's menu to say, print the planet list, the user can just choose that. And then I can through the FileMan API, I can provide those options. I can provide the print template I want to use, and it'll just pop up the actual report output. So that's what these data dictionary utilities are all about. Particularly then list file is this produces developer documentation so that you know what fields are in files, how they're laid out, all of those kinds of things, because that could be information you need to actually build your application, of course. So with that detour of data storage, let's go to the last part of the video here. We are going to make the form. So that's under other options. So we can just type other. And under other options, you see here a number of things. The one we're interested in is ScreenMan. And under ScreenMan options, we can edit and create forms, and then we can run a form to test it. So let's edit create. So I'll just type edit here. And it's asking what file do I want to create a form for? Yep, we're going to stick with our planet file. And then what form do I want to edit? So you can have multiple forms associated with it, right? You might have a simple form for a brief edit, right? Different forms for different scenarios. Again, your application might pop up different forms for different reasons. So I'm just going to call this the edit form. This is just going to be the main planet edit form. Yes, it's a new form. Do you want your form to begin with a display of all entries for selection? No, we're just going to make this specifically for editing a planet that we've already selected. And here's the form editor. So the form editor is itself a full screen sort of ScreenMan program, but it has special capabilities here, as we'll see. So forms can have multiple pages, and you can see we're on page 1 of the form. So when I create a new form, I automatically get the first page. I can move with the arrows, and you can see it tells me where on the screen I am, row and column. But you cannot put fields directly on pages. You can only put fields in blocks. So blocks go in pages, and blocks can actually be reused between forms and between pages. But we'll just make a single block for this page on this form. And so the block is going to start wherever my cursor is. So I'm going to put the cursor back up to the very upper left corner here, row 1, column 1. And I'm going to hit the F2 key and then B for block. And that will create a new block. So F2 is how you create things. F will create fields. B will create blocks. So F2, B for block. I need to give the block a name. I'm going to call this edit main. Are you adding edit main as a new block? Yes. Are you adding it to this page? Yes. And you can see here, it pops up some various options for my edit block, none of which are particularly important to change right now. This is basically the block in the form and then the block in the block file itself. Because again, I could reuse this same block across different forms. But this is all good. Edit main is good. it's an edit form. You can have display only forms or blocks. So I could have a little block that just maybe displays, reference data about the planet I'm editing. If I then have a bunch of other data that I want to actually edit. So maybe I'd have a form that you can't change the planet name and radius, but it would then just have an editable portion where I can edit all the moons. But for now, we'll just say, yeah, we can edit everything. Or that this block is an edit block. You can still lock particular fields if you want. And the DD number, data dictionary number. So this is the file that this block can have fields from. And 999003 is the main planet file. So that's all good. And then you can see down here, we do want to save this block definition and exit. So again, exit always saves. So you can just type exit and that will save it. If I type F1V for block viewer, here's where you can see the layout of blocks on this page. So I have my edit main block. That's the only block on the page. So F1V again to switch back to the main screen. At this point, I can start adding stuff to my form. So it's pretty much WYSIWYG. So I can move my cursor around. I can type F2 and then the letter F for field to add a field. It's asking what block this field is in. Edit main is correct. Field order is the direction that the enter key will navigate through the fields, or the sequence the enter key will navigate through the fields. And then field type, a data dictionary field is an actual field from the database. A caption only field is if I just want to put a label on my form somewhere. So caption only, exit to save that field. And then I have properties for this field. It's a caption, so I'm going to say edit planet, and I'll just put that up at the top of the form. Exit that to save it. Okay, well, I don't like where that field landed, so I can go on the first letter of a field and hit spacebar to select it. Now that it's selected, I can move it around wherever I want on my form, or technically in my block. So let's put it, up at the top in the middle, hit spacebar again to unselect it, and now I'm ready to add another field. So F2F to add the field. And this time I will add a data dictionary field. Field orders 2. So the field in this case is going to be the name of the planet. That'll automatically change just the field ID number. Other parameters here, if you hit enter in one of these little pop-up parameter fields, you can see other parameters. So yes, it's required. And then you can see other... I can change the length of the field on the page. So the planet name can be 30 characters, but maybe I just want a field that is 15 long, and then I have to sort of zoom into the field or navigate inside of it to get the full planet name. But we'll just leave it 30 for there. And we'll close that. Caption is going to be whatever the name of the form field is. And we won't get into this advanced stuff, but again, we can have branching logic. You can do run code before and after the user's in the field, all sorts of stuff. So this is why the FileMan developer guide is, 600 pages, 700 pages. The ScreenMan documentation is inside of that, and you can do all sorts of complicated stuff. But for now, we'll keep it simple. And so this is actually a bug in FileMan, I think. Notice nothing happened here. The reason nothing happened, let me do F2F again for a field, is when I went to the end of the form there, let me just jump to the end with a caret. Yeah, see, it's not doing it this time. So I don't know if you noticed, but it only gave me the option to close the form. It didn't give me the exit, save, refresh, quit options. So it treated it, I guess, as a pop-up and not actually saving data. So closing a form, nothing really happens. You actually have to save it or exit it to save and exit for it to take effect. So if I hit E here, now I got my field. So I'm not sure what triggered it to not offer me the actual save and exit options. But we'll probably see that again. So pay attention to that because it can be frustrating to lose all that data you entered and then not have anything happen. But that's neither here nor there at this point. Similar to the caption, I can hit spacebar on the first character to move my field around. Spacebar on the data entry portion allows you to move that around independently. So now this field can move around in that configuration. But I think I'm going to go with this layout here. We'll have a name. Let's go over here and maybe add the radius over here. So F2F again, data dictionary field. This is going to be, again, you can hit question mark here, and then down in this little area, you can see your field list. And I can just directly enter the number 1 for mean radius. Don't really care about other parameters. Maybe I'll give the user a hint that this is in kilometers. Yeah, so it's giving me the exit here correctly again. Maybe it's because I popped up another pop-up. That might have confused it. I don't know. So I exit, and there's my mean radius. Let's maybe move it over there. And I think that's fine. So what else do we have? We have the spacecraft. Let's go ahead and do F2F. Add another field there. The flyby spacecraft was field number 2. So I'll just do 2. It pulled in the title. I guess that's as good of title as any. So we can just save that field. And let's see if this fits. We might need to move these fields over a bit. So let me just pull that over. Pull name over. We'll drop the date down here. F2F. Yep. Date was field 3. And we will call this closest approach. Again, instead of entering through all these, I can do a caret. And that'll drop me right down to this little command bar. So just different ways of navigating around. You can also directly do F1E for exit and save. Okay, so that's fine. This isn't the most beautiful form layout, but we'll do what we can here. You know what we can do? We can say, so if I highlight a field with spacebar and I hit F4, that gets me back to the properties to edit the field. So really, we only need to display 15 characters of that. And then if I do F1E here, yeah, it saves that. But notice, if I go into this and I just do enter through all of it, yeah, it's just offering me close there, which I'm not actually convinced would save any data changes. Yeah, so that's a bug. So I'm going to not close. I'm just going to go back up here and I'm going to hit F1E, which will then actually still save, do the exit and save operation. So, okay, let's pull these back in, make it a little more balanced. Maybe closest approach. And then the first craft we'll do like that. So now the moons. The moons is the interesting part because there can be more than one. In fact, there can be an unlimited number of moons. So a block can only have fields from one file. And in the case of moons, those fields in moons actually count as a subfile. So I can't put the fields from the moon subfile directly in this block. And even if I could, I want the moons fields to repeat. So the way you do that is you actually make a new block. And I'm going to create the blocks starting maybe down here. So I'll position my cursor to where I want the new block to start. And I'll hit F2B to make a new block. And we'll say this is the edit moon multiple. Yes, it's new. Yes, I'm adding it to this page. And now I have block properties for the edit multiple moon. If you go into other parameters, we can set replication. So this block, I'm going to say repeats 5 times. Saw the number 8 up there. Let's show 5 moons on the screen at a time. Now, again, this is where that bug's going to pop up. Yeah, we don't want to close this. I want to save this. So I'm going to say F1E to exit that form. Okay, so now if we go back, we can verify, yep, it saved the replication setting. F1E to exit that pop-up. We don't care about that. We don't care about that. We do care about the data dictionary number that the fields in this block can edit. This is why I wrote down earlier that 999.003.04. That's the subfile that has the moon fields under the moon index in that planets file. Okay, so it accepted that, 999.003. Again, I'm going to hit F1E here to make sure that saves. And now if I go to the block viewer, F1V, you can see that we have that edit main block. But then now, starting here, and this will expand out as needed down and to the right, I can have the edit moon block, which is going to be repeated 5 times. It'd be kind of cool if they actually showed you the repetition of 5 here, but if I select that, if I hit F4, you can get back into this page here. F1E, exit back out of it. F1V, get back to the main thing. So I just sort of have to know that my block is here. And in fact, let me get back to the beginning of it. So I'm going to add the name of the moon field right here, the second character position in my block, because I think it'll put the plus to indicate that there's more data available back 1 character before it. So starting here, let me hit F1V to get back to this main page. And then I'm going to hit F2F to add a field. And this time the block is going to be the, what did I call it? The edit moon. Yeah, edit moon multiple. This is the first field on that. And it will be a data dictionary field. Exit that. The field here is going to be 0.01. So again, I'm in the moon subfile now. So the primary key of the moon is the moon name, which is field 0.01. We don't need other parameters. And I'm going to delete the caption. So the @ sign, like deleting records, also just deletes any value out of a field. So I'll hit @ there. Because I'm going to have the caption, I'm probably just going to make some column headers at the top. Go through all of that. Again, very important here. If it says close, you need to get out of that bottom field and just do F1E. But in this case, because I didn't pop up a pop-up, it's offering me the exit option. So there we go. There's my unlabeled moon name. And then next to it, let's do F2B. Oh, sorry, not F2B. Cancel out of that with, okay, I can just tab out of that. F2F for a field. This will be the second field on the edit moon multiple. And again, if you don't remember your fields, just hit question marks. And I have 0.01 is the moon. And on the next page here, you can see field 1 is the main, the mean radius. So field 1. Again, no caption, so I'll just hit @ there, and I can just hit F1E here to exit and save that, and that gives me my moon data. So now back up in my main block, right? If I hit F1V, you can see I'm above the edit moon multiple now. So I'll hit F1V again. I'm going to hit F2, actually I'm going to go one more up, and I'm going to hit F2F to add a new field, and this is back just to my edit main. So there's a case where I didn't type enough for it to pick from the 2 potential options that start with edit. So I can just pick the first one with number 1 there. Oh, that was a mistake. I wanted a caption field. So I'm just going to go caret, and I'm going to say quit. So that'll quit without saving. F2F for field. I want a caption only field. And I'm going to say moon name. Exit and save that. And then I'm going to put, you could put a little dashes to make a line. Maybe I'm just gonna, I won't bother doing that. I'll just put the moon name there, and I'll put the radius here. So F2F, caption only field, radius in kilometers. Perfect. So that's it. I've defined my form. We have this block that should repeat 5 times. We have a couple of fields from the main section of the planet form. So I can hit, as you can see, F1S does save, F1E does exit, the normal stuff. Exit should save, but I'm going to do F1S just to be safe, and then F1E to exit. And now the other option in ScreenMan is to run a form. So let's go ahead and just type run. It'll ask what file we want to run a form on, planet. If I look at my forms list, you can see that I have my edit form. And then what planet do I want to run this form on? So here I can say Jupiter. And it works. Almost. Okay, so we didn't leave enough room for the date here. We can edit that. That's no problem. You can see here that obviously it pulled the values from the database. If I tried to change Pioneer 10 to Mariner, if I just partially type in that field, it will pull from that file correctly. If I add a new spacecraft, it will then ask, do I want to add a new record to that spacecraft file? No, I don't. So then it's saying, well, okay, then you need to pick from one of the existing ones. So let's go back to Pioneer 10. And then the moon list here works. So I can edit the moons and I can edit the radius. I can add a new moon. And I can just keep adding moons indefinitely. It'll start scrolling the list here. And you can see, yeah, that plus sign that gets added right next to the field indicates if there's more data above and below to scroll. So in this case, I can both scroll up and down. And then there's always one last row at the bottom of the moon list to keep adding more moons. If I want to delete those moons, of course, I hit @ and it says, are you sure you want to delete? Yes. And then I can just delete all these bogus moons. Whoops. Yes. 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 You get the idea. If I were to add a legitimate new moon like Ganymede, of course, that will get saved to the database. So Ganymede is 2,634.1 kilometers. So if I exit from that form, we can go back out to the top of FileMan. We can say print from planet. We can use our planet list print template. And you can see now that Ganymede has indeed been added to the moon list because we added it to that form. So that's it. Of course, we can go in and we can fix that date field so it's not cut off. But I think at this point, you understand how to do that. You would just go in, you hit the space bar, you can move the field over. You might need to then edit the properties of the field with F4, where you can then change that field length if you need it to give some more characters. But the reason it did that is because I added the field with not enough space left on the right side of the screen. So it just automatically truncated the length of that field for me. That's it. That has been quite a lot of information, but again, I hope it was an interesting demonstration of FileMan and then the ScreenMan component of FileMan, where you're able to define your data dictionaries. You're able to use that text user interface to just enter data and edit data. We didn't even really get into, I can show you that we can search for data. So one of the options here was to search. So I can search the planet file. Maybe I want to find planets with a mean radius greater than 7,000. Those are my search conditions. And then we can just print it out here. I can use that print template, planet list. And now I've done a search and it's restricted it to only the planets with the radius greater than whatever I said, which excluded Mercury. So again, you can search on multiple fields. You can do all sorts of stuff. You can do the pointer searches by doing that field name : launch date, for example, like we did when defining the print layout. So lots and lots of capabilities here in FileMan for you to use as building blocks for your application. But if we look over at the web browser one last time, I'll just leave you with, the next steps is on your own. Go ahead and build that particular version of RSM that I mentioned. V1.76.0 is the tag, and then import the latest version of the utils. And then you can import the FileMan MUMPS routines here, and the instructions here tell you how to rename all of that, and then initialize it. And from there, just go to home on hard hats here, Vista related links, documentation library, go down to infrastructure, go to FileMan, and here you have those hundreds and hundreds of pages of documentation on FileMan for you to read that will hopefully get you off the ground in terms of developing some kind of application with FileMan. As always, thank you so much for watching. Any comments, questions, please feel free to leave them below. Hope you enjoyed this introduction to FileMan. It's a really interesting tool in the sense of course, it gives you the foundation to build applications on, but your application administrators would potentially be given access to the actual raw underlying FileMan tool. So even though you're users, you probably build screens and you build your own application flow to move them through it. It's really convenient as an application administrator or the developer not to have to build out forms and screens for maybe just some internal configuration data, that once you define the file layout, you can just use FileMan's built-in interfaces here to update that and edit that. But yeah, really, really interesting foundation in MUMPS to build powerful data-driven applications on. So give it a try. Let me know what your great idea is for building a new application in the year 2023 from scratch in MUMPS on top of FileMan, and I'll love to see what you come up with. So thanks again for watching, and I'll see you next time.